In this video, I'll walk you through the basic steps to take in order to optimize your portfolio. I'm using the same example from previous videos where I have a series of companies, company A ranging to company H, and I have monthly returns below. Again, these are returns for each stock per month. These are not the prices for each stock. I've already done the conversion from price into returns. So from November to December for company A, I can see a 2.5% return. This data goes from 1995 through 2000. So to make this video a little cleaner to read, I'm going to hide some of the data. That way you can see all of my formulas. So the first thing we need to do is calculate the mean return or average monthly return for each stock. So if I click on cell B65 in my spreadsheet, I can see the formula that I've included here is equals the average of cells B3 to B63, and that's simply the average of all of the returns for company A. So I'll just delete this and illustrate it for you. Equals average, open parentheses, highlight all of the returns, close parentheses, and you can see my mean return. It's my mean monthly return. The standard deviation is simply the standard deviation of the monthly returns. Again, the same logic. It's a simple code. It's equals STDEV, and then again I highlight the cells for which I want to calculate the standard deviation. So just to walk you through it, equals STDEV, open parentheses, highlight all of my returns. I'm not highlighting the top row, which is the company name. Close the parentheses, hit enter, and you have your standard deviation. Because these two numbers are monthlies, we need to annualize them, which is what I do down below. To annualize the return, you can view my code here. It's equals, and I'll have to use two parentheses, 1 plus the monthly return. In this case, my monthly return is in cell B65. So 1 plus the monthly return raised to the 12th power. I'm raising it to the 12th power because I'm using monthly data. If you're doing this project with weekly data, you're going to raise to the 52nd power. And then don't forget -1 on the end. Okay, so I can see 0.46 or a 46% annualized return. To annualize my standard deviation, the formula is just going to equal the monthly standard deviation, in this case cell B66, my monthly standard deviation times the square root of 12. I'm using 12 again because I have monthly returns. If you were doing this with weekly data, you would use the square root of 52. In Excel, it's a little bit easier. Rather than taking the square root of something, you can just raise it to the half power, and so that's what I've done here. I've just raised 12 to the half power rather than taking the square root. Okay, I do that for all of my stocks, and now I have some projected data that I can use to optimize my portfolio. What I'll do is I'll copy this data and move to a new worksheet. And what I've done here, I've already pasted that data up top. I use the transpose function to make it vertical because that's going to make copying formulas a bit easier for me. Another thing I've done, you can see my return rather than being 0.46. I've just multiplied everything out by 100 so that it's easier for me to read. It's 46.6%. I did the same thing with all of my standard deviations as well. So all of these numbers have been adjusted accordingly by 100. Next on this page is the correlation matrix. In a previous video I showed you how to build this matrix. I've just copied it in here and pasted it. Moving on, we'll need to build a covariance matrix, which is down below. And what I'll do quickly is pull in a slide from class. This is the slide we used in class when we discussed covariance and correlation. If we look down here to the bottom, we can see the correlation between stock J and stock K is equal to the covariance between stock J and stock K divided by the product of both standard deviations, the product of the standard deviation of stock J times the standard deviation of stock K. Therefore, we can just reconfigure this formula if we'd like to know how to get covariance. Right? And we can see that the covariance of stock J with stock K is simply the correlation of stock J and stock K times the standard deviation of stock J times the standard deviation of stock K. This formula right here is going to be crucial for the project. We're going to build the covariance matrix, and the formula we're going to use is for every asset pair, we're going to use the correlation of that asset pair times the standard deviation of each asset. So you can see I'll begin with company A versus company A. When I click in that cell, my formula is going to give me the correlation of company A to company A times the standard deviation of company A times the standard deviation of company A. And you can see up top here, it's exactly what it does. Cell C14 is the correlation of A to A, which is 1, times D2, which is the standard deviation of A, times D2, again, standard deviation of A. In this case, we're comparing A to A, so it's simply giving us the variance of that company. Let's go down to A to B. Same concept, the correlation of A to B times the standard deviation of A times the standard deviation of B. And we can see in the formula, I've just moved down one cell, so now it's grabbing the correlation of A to B. It's grabbing the standard deviation of B, and then the standard deviation of A. Okay, and I'm going to go ahead and repeat this process to build out my covariance matrix. Again, referring to slides from class, once we build out this entire matrix, you're going to have something that looks like this. In this case, I did n number of stocks. Yours will be 5 stocks, so yours will kind of end right here. But for stock 1 to stock 1, you're going to have variance. For stock 1 versus all other stocks, you will have covariance. And this is the variance matrix that we're going to build out here. At the end of the day, just looking at the 3-asset portfolio, to get the standard deviation of the entire portfolio, and if you recall this from class, this is 3 assets, but if we have 5, we can just extend the equation. It's the weight in asset 1 squared times the variance in asset 1. Weight in asset 2 squared times the variance, right? This is our summation of variances. To the right, this is our summation of covariances. Weight in 1 times weight in 2 times covariance. The reason we have this 2 here is because stock 1 to stock 2, this cell is exactly the same as stock 2 to stock 1. So let's come back into the system. We've built out our covariance matrix. Now we need to take the covariance matrix and extend it to include the weights of the different stocks. And that's what you're going to see down here. I've added a column here called weights, and I've added a row for weights. So since I have 8 stocks, I'm going to go in here real quick and just start off with a portfolio that is equally weighted across all the stocks. It's important to note when you add up all your weights, that final cell here, they total 1. So you can see that final cell is the sum of all the weights. Has to equal 1, right? Your portfolio cannot exceed 1 or be less than 1. The weights across the top here are just a mirror image of these weights right here. So be careful, do not enter numeric values in these cells, but instead, if you see my formula, it's just mapping back, it's equaling cell B39. Right? If I went to this cell right here and look at the formula, it should map back to this cell here, B41. And you can see that it does. The reason for this? The reason for this is so that we can easily change weights in this column, and it will automatically change the weights across the top. So for example, I'm going to change the weight for company A here, and you'll see it update instantly on this side. So say I took a 25% weighting to company A, it's going to go ahead and recalculate everything for me. Okay, so now that we have the column and the row in place for weights, we can put together the formula here to determine the variance of the entire portfolio. For company A and for each subsequent company, the formula is simply going to be the two weights multiplied out. So if you look up here, B39 times C8 multiplied by covariance. And in this case, I'm going to map back up to the previous matrix. All right. We go down to company A versus company B. The weights are going to be cell B40 times cell C38, and then multiplying that by the covariance between A and B. And that's what you're seeing up top. So pretty simple formulas, you just have to work your way through. Ultimately, the last few steps here, when you have all of the covariances in place and variances based off of weights, you can sum each column. So for company A, I'm going to sum the variance and covariances. Be sure not to include the weight, and you can see the sum is 57.69. If I click on that column, you can see my formula there. I'm just summing. I'll do that for each company, right? Just summing up these columns. So ultimately, I have total variance calculation for each company. The last step here is to add all of these variances and covariances. That's going to give me my total portfolio variance. So you can see the formula for this cell is simply summing all of those individual variances. Right, now we're at the point where you can answer the 3 questions of your assignment in the next minute. Now it's very easy. So we have variance. We can get standard deviation just by taking the square root. So you can see I've just raised variance to the half power. Based off of these weights and going to the top and the projected returns, I can determine the portfolio mean return, which is just a sum of each individual stock's weight times its return, right? Plus the next stock's weight times its return, plus the next stock's weight times its return. And I can just repeat this process. So one of the questions you're asked in your assignment is to produce the weights of each security that you should use in order to create a portfolio that has the minimum variance. In Excel, this is really easy to do by using one of the tools. So I'm going to go up top here to Data, and I'm going to use the Solver add-in. Okay, and I'm going to delete the data that was in here before. Okay, so what we need to do is minimize the variance of this portfolio. So the target cell is going to be just that, the variance cell. What we want to do is set it equal to the minimum possible value. So we want to minimize variance. By changing cells, well, we want to change the weights of each security. So by changing cells, I'm going to go ahead and highlight my weights. Okay. The last step here is we have to give one constraint, and that constraint is that the weights total 1. So I'll click here to add a constraint. I have to reference a particular cell, so I'm going to reference this cell right here and set it equal to 1. Add it. And now I'm all set. The last step here is hit the solve button. You can keep your eye here on the weights. I'm going to hit solve, and you can see Excel told us we should short company A, short company B, and the appropriate amounts to buy of the remaining 6 companies. As a result, we get the minimum variance of 278, which is a standard deviation of 16.7, results in a portfolio return of roughly 32%. The next 2 questions are designed for you to maximize the slope of the capital allocation line. That's the Sharpe ratio. You can see the formula here. It's the return of the portfolio less the risk-free rate, which I'm using 5%, divided by the standard deviation of the portfolio. Now all I have to do is use Solver, and rather than minimizing the variance, I'm going to set my target cell to be the Sharpe ratio. I can maximize it. Changing cell stays the same, constraints stay the same, and now I can solve to get the highest slope for the capital allocation line.